Hey, scientists. So today we are talking about work. And so when you think about work and you describe something that has a lot of work associated with it, usually what comes to mind is something like school. School seems to be a lot of work. Or if you look at, working at your computer, that's a lot of work. Okay. Sometimes people may think of something like lifting weights or exercising, all right, or this one, he's doing sit ups, as a lot of work, okay? But really, when you describe work, we want to think about using a lot of force. So, like construction, something like this. So, they are lifting the walls on this one. That would probably be a little bit more work, okay? If you think about the motivational quotes we see sometimes. So this one says, it takes a lot of hard work to make something look simple, okay, by Steve Jobs. Well, in actuality, if we look at this scientific way to measure work, that may not be an example of a lot of work, okay? So today, when we're looking at scientific work, here are just some of the things that come to mind. Scientific work is going to be different than maybe how you perceive work, okay? So how to figure out scientific work, you need to take a force and move it a distance, all right? So when you think about moving something really heavy, like lifting weights, that would be an example of a lot of work. Whereas if you're just writing something down, moving your pencil probably doesn't take a lot of force to move that distance, so not a lot of work. So we need to kind of redefine how we think of work scientifically, okay? So here are just some words that come up and come to mind when we think about scientific work. And I want you to look at this word right here, energy. Okay. So with energy, you need energy to do work. So the ability to do work comes from that energy that you have. Okay. And it can be in different forms here. All right. Now back to our discussion about work. Work, if we take a force times a distance, I want you to think about what units this would be measured in. Okay. So force, we use something like a spring scale. So this is our spring scale that we've used before in class. And this one is measuring in newtons. Okay. So we can have newtons would be for the first one. And so force is usually measured in newtons. Distance is measured in meters. Now, if we have our handy dandy rulers right here, we might have something that's measured in inches or centimeters, and we're going to use meters to determine the amount of work done. So our new units are really just Newton meters. Okay, we can abbreviate that by looking at N, capital N, lowercase m. Okay, so a Newton meter is just written out N, capital N, lowercase m. Okay, or sometimes we shorten some things as well. So this could also be measured in joules. So 1 Newton meter equals 1 joule. Okay, they can go back and forth. Typically, we're going to see Newton meters used when measuring work. Okay, because again, that's a direct force times distance. And joules is usually associated with energy. Okay, but you can use either one. Now, when you think about the amount of work done, imagine that I have this tall mountain, all right, and this is in my very crude drawing of the tall mountain, and I want to get to the top here. So the letter D represents the top. I can either take path A, all right, which in path A, if you notice, is pretty steep, okay, to get to that top of the mountain. B tends to wind around a little bit more to get to the top of the mountain. And then C, you can't really see this right here, but C is right here and it's less steep than A. So think about work as force times distance. And which one do you think would be the least amount of work? So I want you to think about that as we go through our lab today, okay? We're going to practice measuring some work. So which one do you think would be the least amount of work? Path A, path B, and again, C is this line right here, or are they the same amount of work? Okay. Now the get to work lab that is posted is I want you to think about newtons from the spring scale, meters from a meter stick. So we have Newton meters, okay? So in this investigation, think about what it means to do work. And this is the scientific way to calculate work. I want you to think about how is it measured? How do you calculate it? And what do the units actually mean? Okay. If we were in the lab, we would be taking then our handy dandy spring scales, all right, and lifting different objects. So I have my notebook right here, all right, using this formula, force times distance. So if I were to lift this notebook, okay, and this is reading, it's about a little over 3 newtons, okay, and I measure it like over a distance. If I set up my ruler here, and I know that this is see-through here, but if I just lift it, let's just say 10 centimeters, okay, that's all that I want to measure. So you would then write out that example. So I have my force is 3.25 newtons. The distance is 0.1 meters. Okay? So to find work, you just multiply those two out and you get 0.325 newtons. All right. So that's an example on how you calculate work. Now your mission, again, think Newton meters, is to use this sample data. This is data that I have collected in the lab in past classes. And we're going to lift things up vertically, but then also see how much work it takes to drag them horizontally off a surface. Okay. So you can see this first example, I have the handy dandy textbook right here. Okay. And if I lift this up, it takes about 18 newtons, and the height of the lab tables that we have at school are 0.92 meters. So how much work is done to lift that textbook up vertically and then to drag it across the lab tables? It only takes 2.8 newtons, okay? So we would then multiply those out to determine the amount of work. So your mission, using the sample data, determine the amount of work done in each situation. So show your work, show what you multiply, okay? Then the second thing here is to estimate how much work you can do in 60 seconds, okay? So pick one of these sample data, and I want you to just estimate. So this leads to our next formula that we're gonna discover later too. But think about which one of these things are you going to move? How many times could you lift it up and down in 60 seconds and then figure out the amount of work done per 60-second period? Okay, so think about that. What would the units be in? All right, and then that will be part of the lab. And then there's some analysis questions to go along with it. As always, if you have any questions, please reach out. Have a great day, guys.